In the last video, I basically showed you what was the usefulness of logarithms rather. And in this video, I'm going to show you the relationship between logarithms and exponential functions. So let's go back if you remember what exponential functions were. So let's say, for example, I give you an exponential function like 2 to the power of x, and I ask you, find its inverse. Okay? So if I want to find its inverse, the first thing I have to do is I have to switch, x and y, and then I have to solve for y. Now y is in the variable, y is the variable, but it's in the exponent. So in order to sort of solve for it, I need to apply logs to both sides. So let's say I apply log of x. Remember, I could have put ln or log, it's the same thing. So I'm going to put log just for now, and this is 2 to the power of y. I could also put brackets around here, and it's always a good habit to put brackets around the log. Now, due to the log rules, I can bring the y down. And that's why I applied log to begin with, because I wanted to bring the y down from the exponent down to the base, or to a coefficient. So this becomes log of x is equal to y log of 2, right? And what I'm going to do here is y then becomes log of x divided by log of 2. And if you remember the change of base rules, it doesn't matter, like basically when you have a log over a log, this just becomes log base 2 x. If you're confused by this, just go back to the video where I talk about the change of base, and this should make sense. So you should be comfortable going from this form to this form and vice versa. You need to be comfortable going between these two forms. So in this case, y is equal to log base 2. So what's interesting is that here is an exponential function, and its inverse, the inverse of an exponential function, turns out to be a logarithm, a logarithmic function. So that's basically the tie-in with exponential functions and logarithms. They are inverses of each other. So that's the key thing. You must remember that logarithms are inverses logarithmic functions are inverses of exponential functions. I'll just write that down. Logarithmic functions are inverses of exponential functions. Okay? This is key. This is really, really important. So say, for example, I have, let's just use this line feature here, if I can. So, oops. Oh, no, I think it's just a black line. A second, let me just do this. Let's say I have a line over here, and then I have another line over here. Okay, and say, for example, I draw a function y equals 2x, for example. Right, so remember, there's a plus 0, so there's an asymptote right here. Okay. Okay, so it goes like this. Okay, so let's say, for example, I take a point on this function. Okay, so this is like this y function right here. Y equals 2 to the power of x plus 0. Okay, so say, for example, I take a point right here, which is, 2 to the power of 4 is 16. Okay, so that's the point over there. Okay, now let's just say, for example, I want to find what its inverse is, right? And as we know that the inverse of an exponential function is a logarithmic function. And so if you recall the inverse is, it's just basically a reflection across the line y equals x. It's just a reflection across that. So the inverse function would basically look something like this, right? Right? It's just a reflection. Like, imagine if this were a mirror, this red line, if it reflected across, would be this blue line. And this blue line is the logarithmic function, which is y equals log base 2 x, which we just found in the previous slide. So the question is, how would this point reflect across the other points? So remember, when we do the inverse, all that happens is that the x and y switch. So this point would be reflected that way, and it would be 16, 4, because it's just a reflection across the that green line, which is y equals x. So I'm just going to write that's y equals x. Or maybe if you can't see that, that's y equals x. Okay? So that's the important relationship, that exponential functions are inverses of logarithmic functions and vice versa. So if you're given a logarithmic function, you should be able to find the exponential, and if you got the exponential, you should be able to find its logarithmic function, or its inverse. All right, I hope that helps. And in our next video, oh, wait, sorry, one more thing. So along with the idea of that, so keep in mind that e of x, right, is basically the inverse, right, is the inverse of ln x. Okay, so these two functions are inverses of each other because this is e to the power of x and ln x is log base e to the power of x. So these two are inverses of each other. So it's very, very important to remember that. Okay, so that's it for now. The last video that we have is I'm going to show you how to draw logarithmic graphs, and that's going to be our last video, sort of as a review for this section.